Did you know there's a secret American aircraft that may have cost over $1 billion and officially doesn't even exist? A machine capable of crossing continents in minutes, reaching Mach 6, and vanishing from radar like a ghost. But if it's just a myth, why are China and Russia scrambling to catch up? In this video, you'll uncover the secrets of the SR-72 Darkstar, the fastest, most expensive, and most mysterious military aircraft ever conceived. A true legend that defies the limits of engineering and perception. Imagine an aircraft so incredibly fast, it can cross oceans before the enemy even realizes it's there. That's the promise of the SR-72 Darkstar, affectionately dubbed the son of the Blackbird, in reference to the iconic SR-71. More than just a successor, the Darkstar represents a quantum leap in aerospace warfare, designed to operate where no other manned aircraft has dared, the hypersonic frontier. It's not just a plane, it's a declaration of intent, a harbinger of the future of aerial combat, where speed and stealth become the ultimate weapons. Unlike any fighter jet or spy plane ever built, the Darkstar was born under an almost impenetrable veil of secrecy. For years, it was merely a rumor, a whisper in defense circles, a phantom in classified files, an urban legend among aviation enthusiasts. It wasn't until a brief but stunning appearance in Top Gun Maverick that the world caught its first glimpse of what might already be soaring through our skies. This appearance, though fictional, ignited the public's imagination and raised questions about the reality behind the myth. But the truth goes far beyond Hollywood. The SR-72 is not just a concept, it's a real government-backed project fueled by decades of research and development funded by black budgets, secret funds allocated to highly classified programs. Now, as China and Russia race to develop and deploy hypersonic weapons, the Darkstar may be America's invisible ace in the global game of air dominance. Its existence, even if not officially confirmed, serves as a powerful deterrent and a catalyst for continuous innovation in the hypersonic arms race. The ability to operate at extreme speeds and altitudes, combined with its stealth, makes the SR-72 an invaluable tool for intelligence gathering and, potentially, for precision strikes in the near future. When the SR-72 appeared in Top Gun Maverick, most viewers assumed it was pure science fiction, a fantastical Hollywood creation for public enjoyment. However, insiders and those with knowledge of defense programs knew that the reality was far more complex. The model used in the film was not just a random artistic creation, it was designed in direct collaboration with Lockheed Martin's legendary Skunk Works, the same visionary team behind the original SR-71 Blackbird. This strategic partnership between the defense industry and the film industry added a layer of realism and mystery to the aircraft, blurring the lines between fantasy and classified reality. The replica was so convincing, so eerily precise in its details, that according to reports, it triggered intense satellite surveillance by Chinese intelligence. Why? Because what was shown on screen bore an uncanny resemblance to classified design schematics, information that was never intended to be seen by the public. Suddenly, a mere movie prop transformed into a global intelligence flashpoint, generating concern and speculation in capitals around the world. The public display, even if fictional, of an aircraft with characteristics so similar to real secret projects was a bold and unprecedented move. In a word, speed. In today's era of real-time warfare and near-instant surveillance, the ability to outrun enemy systems in speed is the ultimate strategic advantage. The SR-72, with its ability to fly at Mach 6, 6 times the speed of sound, can penetrate hostile airspace, gather intelligence, or conduct strikes, all before enemy radar even detects its presence. This extreme speed is not just an impressive number, it's a game changer that redefines combat tactics and the dynamics of global power. The ability to operate with such rapidity means the SR-72 can evade air defenses, outmaneuver interceptor missiles, and complete high-risk missions with an unprecedented level of security. Imagine this, a jet that can penetrate the world's most secure airspace, complete its mission, and disappear, all in a matter of minutes. It's no longer just about stealth, which focuses on avoiding detection. With the SR-72, speed becomes a form of active stealth, where the aircraft is so fast that defense systems simply cannot react in time. It's about rewriting the rules of engagement, transforming the concept of aerial warfare. The SR-72 represents a level of power that rivals are not just nervous about. They are desperately scrambling to match, investing heavily in their own hypersonic research, often without the same level of success or secrecy. This is not fear of what the Darkstar is today. It is fear of what it means for tomorrow, because any nation capable of engineering something this fast, this invisible, and this lethal may already be decades ahead in the next generation of warfare. The hypersonic race is not just a technological competition, it is a race for strategic supremacy. The nation that masters hypersonic speed will have a decisive advantage in future conflicts, capable of conducting precision strikes with very little warning time or gathering intelligence in highly contested areas without risk of interception. The SR-72 is, therefore, a symbol of the future of warfare, where speed and agility will be the most valued attribute. Want to become a military aviation expert? Subscribe to our channel and turn on notifications to receive exclusive content about the world's most advanced aircraft. Hypersonic flight is not just futuristic, it's brutally real and represents a monumental challenge for aeronautical engineering. Exceeding Mach 5 times the speed of sound, means confronting aerodynamic and thermal forces that simply disintegrate conventional aircraft. The SR-72, with its goal of reaching Mach 6, demands a complete reinvention of how we build and fly planes. We are talking about new materials that can withstand extreme temperatures, new engines capable of operating in airflow regimes never before achieved, and new flight protocols that manage the complex dynamics at hypersonic speeds, all in a cohesive and functional package. The complexity involved is so vast that every component, from the structure to the internal systems, needs to be redesigned from scratch using the most advanced modeling and simulation techniques. This technological race began during the Cold War with projects like the X-15, but today it is entering overdrive, driven by advancements in materials, propulsion, and computing. The United States, Russia, and China are all in a high-stakes sprint to build aircraft that can not only fly fast, but also execute missions with deadly precision, all while remaining invisible to traditional radar systems. The competition is fierce, and success in developing and deploying hypersonic capabilities is seen as a key indicator of military and technological power in the 21st century. The ability to deliver payloads, whether for reconnaissance or attack, anywhere in the world in a matter of minutes, fundamentally changes the dynamics of deterrence and crisis response. Flying at Mach 6 is like navigating through an invisible inferno. The air friction alone heats the aircraft's surface to temperatures that can melt metal. Imagine over 1,000 degree Gar and 500 degree Celsius across the entire surface of the plane. Everything, the cockpit, avionics, external structure, must survive extreme heat and violent gravitational forces. It's an engineering challenge that demands solutions far beyond conventional materials, transforming the SR-72 into a true terrestrial spacecraft. The ability to withstand these extreme conditions is what sets the SR-72 apart from any other aircraft ever built, making it a marvel of material science. To survive this hellish environment, Lockheed Martin turned to space-grade materials. Advanced ceramic titanium composites and metal alloys, previously used in space shuttle designs, were integrated into the SR-72. Every inch of this aircraft is engineered for speed, durability, and sheer survival at the edge of physics. The selection of these materials is not arbitrary. It is the result of years of research and development, testing the resistance of each component under the most adverse conditions imaginable. The SR-72's fuselage is not just a shell, it is a thermal armor designed to dissipate heat and protect internal systems and, potentially, the crew. At Mach 6, traditional jet engines become useless. The physics of air compression at such extreme speeds simply does not allow turbines to function efficiently. This is where scramjets come in, a radical leap in propulsion technology. These innovative engines compress incoming air at supersonic speeds before combustion, eliminating the need for spinning turbines. This allows them to operate at hypersonic speeds, but there's a catch. They only work at speeds above Mach 2.5. Below this speed, the airflow is not fast enough for the necessary compression, and the scramjet simply does not generate thrust. This fundamental challenge required an even more ingenious engineering solution. So how does the SR-72 take off and reach the speed where the scramjet can take over? The answer is simple, yet brilliant. It does not rely on a single type of engine. Instead, it uses a turbine-based combined cycle (TBCC) system, seamlessly switching between a turbojet at lower speeds and a scramjet at hypersonic velocities. It's a mechanical symphony that few nations can even attempt, let alone master. The transition between propulsion modes is one of the greatest engineering challenges, requiring precise control and perfect synchronization to avoid thrust loss or aircraft instability. What if one engine isn't enough? The SR-72 doesn't settle for one solution, it uses two. This aircraft combines the raw thrust of a turbine engine for takeoff and acceleration with the futuristic speed of a scramjet for hypersonic cruising. It's like switching from a jet to a missile mid-flight, a transition that requires precision engineering and unprecedented control. This dual-engine approach is what allows the SR-72 to operate across such a vast range of speeds, from conventional takeoff to extreme hypersonic flight, filling a critical gap in high-speed aviation. The two engines are fed through a shared air intake, but split into distinct airflow paths. Managing this system is not just difficult, it's almost insane. The real challenge is making the transition between modes without the aircraft shaking itself apart or losing stability at Mach 3+. The complexity lies in optimizing airflow for each engine type across different speed and altitude regimes, ensuring both engines receive the ideal amount of air for efficient combustion. Furthermore, the transition between the turbojet and scramjet must be smooth and imperceptible to the pilot, if there is one, maintaining aircraft stability and control at all times. This is one of the SR-72's greatest engineering feats, a testament to humanity's ability to overcome seemingly insurmountable technological challenges. At hypersonic speeds, even the air becomes your enemy. Friction generates temperatures hotter than lava, above 1000 degrees and 500 degrees Celsius across the aircraft's surface. Conventional materials melt, warp, or crumble under this intensity. To survive, the SR-72 had to be built like a spacecraft, utilizing technologies and materials that were previously exclusive to space exploration. The ability to withstand these extreme conditions is what makes the SR-72 a marvel of engineering, a true flying laboratory that pushes the boundaries of physics and material science. Enter titanium ceramic alloys and heat-resistant composites developed for NASA's Space Shuttle program. These materials not only survive the inferno, they thrive in it. Every panel, every joint, and every bolt is engineered to handle the brutal stress of Mach 6 flight. The selection and application of these materials are the result of decades of research and development, ensuring that every component of the SR-72 is capable of maintaining its structural integrity and functionality under the most adverse conditions imaginable. The SR-72's fuselage is, in essence, a thermal armor that protects internal systems and, potentially, the crew from the scorching heat generated by hypersonic flight. Is there a pilot in the Darkstar? This is a question that has generated debates and speculations for years. Rumors have long circulated that the SR-72 would be fully autonomous, a robotic predator designed to operate without human limits, capable of withstanding G-forces and conditions that would be lethal to a human. This idea of a fully autonomous combat aircraft is both fascinating and frightening, raising ethical and strategic questions about the future of warfare. However, then came a cryptic interview with program lead Brian Herberg, who suggested something much more flexible and intriguing. According to Herberg, the SR-72 may have both options, manned and unmanned, depending on the mission. This dual capability opens up an entirely new dimension of operational strategy. Imagine a hypersonic drone one day and a manned strike platform the next. This flexibility is a game changer, allowing the SR-72 to adapt to a vast range of mission scenarios, from high-risk reconnaissance to precision strikes in contested environments. The ability to switch between manned and unmanned modes gives mission planners unprecedented versatility, allowing them to choose the ideal configuration for each specific task. If true, this gives the US an incredible edge. Piloted versions allow real-time decisions in hostile airspace, where human intuition and improvisation are crucial. Unmanned versions push the boundaries of endurance and risk, allowing for longer and more dangerous missions without putting lives at risk. Either way, the SR-72 can adapt to whatever the mission demands, and that unpredictability is part of its terror. An adversary's inability to know whether they are facing an autonomous machine or a human pilot adds a layer of uncertainty and complexity to defense planning, making the SR-72 an even more formidable threat. The enigma of the SR-72, therefore, is not just about its existence, but about its mutable and adaptable nature. Want to delve deeper into defense strategies and the future of aerial warfare? Subscribe and receive exclusive analyses of the tactics and technologies shaping the global landscape. The SR-72 is not just a reconnaissance tool, it's a weapon. Unlike its predecessor, the SR-71 Blackbird, which was strictly a spy plane, the Darkstar is designed to carry hypersonic missiles. That means it can identify a target and destroy it moments later. This integrated strike capability transforms the SR-72 from a mere observer into a lethal executor, capable of closing the sensor-to-shooter loop at unprecedented speeds. The ability to perform reconnaissance and attack with the same platform and at hypersonic speeds is a game-changer in modern warfare. Ordinary bombs cannot handle Mach 6 conditions. The air pressure alone would tear them apart. But hypersonic missiles? They are designed for this. Lockheed Martin confirmed in 2018 that the SR-72 would be strike-capable, marking a significant shift in the role of spy craft. This means the SR-72 is not only an intelligence-gathering platform, but also a precision strike platform, capable of delivering lethal payloads to high-value targets with minimal warning time. The integration of hypersonic missiles into the SR-72's design is a testament to its multifunctional capability and its strategic importance for the future of aerial warfare. It started as entertainment, a brief scene in Top Gun Maverick, but what followed was no mere Hollywood stunt. Chinese intelligence began scanning satellite data, looking for clues. They weren't watching a movie, they were analyzing a threat. This disproportionate reaction to a fictional representation of an aircraft underscores the psychological and strategic impact that the SR-72, even in its speculative form, exerts on adversaries. The line between reality and fiction became blurred, and perception became a weapon as potent as any missile. The SR-72's on-screen presence looked eerily similar to confidential schematics that were rumored to exist on Lockheed Martin's website. Was it a leak, a warning, or a calculated display of psychological warfare? Whatever it was, it worked. The mock-up sparked real-world panic and investigation. The ability of an image, even if fictional, to provoke such a significant response from a rival power demonstrates the power of disinformation and perception warfare in the modern era. Lockheed Martin, by collaborating with the film, may have orchestrated one of the most brilliant psychological warfare campaigns in recent history. Without firing a single shot, the SR-71 Blackbird remains a legend, a Cold War marvel that still holds the speed record for manned air-breathing flight. However, even the best become obsolete. As radar systems advanced and air defenses grew sharper, speed alone was no longer enough to ensure survival in an increasingly sophisticated combat environment. The Blackbird, despite its phenomenal speed, began to encounter limitations in its ability to evade detection in a world with high-frequency tracking systems and real-time satellite surveillance. The evolution of air defense technology demanded a new approach to stealth and survival. The Blackbird flew at Mach 3.2, but it couldn't remain stealthy in a world with high-frequency tracking systems and real-time satellite surveillance. In 1998, it was officially retired, not for lack of power, but because it could no longer outpace detection. Its large silhouette and reliance on speed for survival made it vulnerable to new threats. The retirement of the SR-71 marked the end of an era, but also paved the way for the next generation of reconnaissance and attack aircraft, which would need to combine speed with advanced stealth to operate in contested environments. The lesson learned from the Blackbird was clear. Speed is crucial, but stealth is key to survival on the modern battlefield. Enter the SR-72, faster, stealthier, and potentially unmanned. It's not just filling a gap, it's rewriting the blueprint. Where the Blackbird was built for a Cold War, the Darkstar is built for a digital battlefield that moves faster than politics can catch up. The SR-72 represents a paradigm shift in military aviation, combining hypersonic speed with unprecedented stealth and the flexibility of manned or unmanned operation. It is the answer to the challenges of the 21st century, an aircraft designed to operate in an environment where speed and stealth are the most valuable currency. The Darkstar is the heir to the Blackbird's legacy, taking air supremacy to a new level. Want to become a military aviation expert? Subscribe to our channel and turn on notifications to receive exclusive content about the world's most advanced aircraft. Hypersonic weapons are no longer theoretical, they are here. Russia and China are already testing systems that can travel at 5 times the speed of sound, and the global race for this technology is in full swing. The global arms race has shifted from nuclear deterrence to speed supremacy. This change in focus reflects the understanding that in the near future, the ability to deliver a payload anywhere in the world in a matter of minutes without being intercepted will be key to military dominance. Hypersonic speed is not just a tactical advantage, it is a strategic advantage that redefines the global balance of power. Why speed? Because it's the one thing defense systems cannot fully intercept. The faster a missile or aircraft travels, the shorter the reaction window for enemy defenses. Hypersonic weapons reduce this window to seconds, or eliminate it entirely. In this race, even being in second place means being defenseless. The ability of a hypersonic missile to maneuver at extreme speeds makes interception by existing anti-missile defense systems virtually impossible, creating a new dimension of threat and vulnerability. This forces nations to rethink their defense strategies and to invest heavily in their own hypersonic capabilities, or face the prospect of being outmatched. Officially, the SR-72 didn't exist. There were no publicly confirmed test flights, no government confirmation, no budget trail, just whispers and speculation. This silence was not accidental. It was a weapon in itself. Invisibility not just on radar, but also in official records. The strategy of keeping the project under such strict secrecy allowed development to proceed without public scrutiny and political interference, ensuring that the aircraft could be developed and tested in secret, away from the eyes of adversaries and curious onlookers. Secrecy became an intrinsic part of the aircraft itself, making it a ghost in every sense of the word. From 2013 to 2015, development proceeded behind closed doors. NASA discreetly awarded contracts to study high-speed propulsion. Lockheed Martin quietly ramped up its research and development, and somewhere, out of public sight, the Darkstar began to take shape. This black budget approach and secret development is a common tactic for cutting-edge defense projects, allowing government agencies and defense companies to work without the restrictions and visibility that accompany public programs. The collaboration between government agencies and private companies, under a cloak of secrecy, is what allowed the SR-72 to become a reality. 5 years ago, building the SR-72 would have been impossible. The materials, the engineering, the tolerances, everything was beyond the reach of technology at the time. But then came the rise of advanced computational modeling and 3D printing, transforming science fiction designs into tangible reality. These revolutionary technologies allowed engineers to overcome barriers that once seemed insurmountable, paving the way for the creation of aircraft with unprecedented capabilities. 3D printing in particular enabled the creation of complex components with optimized geometries, reducing weight and increasing strength, something that would be impossible with traditional manufacturing methods. Lockheed Martin embraced additive manufacturing to build lightweight, heat-resistant components with microscopic precision. What used to take years in prototyping can now be produced in weeks, customized, scalable, and mission-ready. The ability to manufacture parts on demand with complex geometries and customized material properties dramatically accelerated the SR-72's development cycle. Furthermore, 3D printing allows for the creation of internal structures optimized for heat dissipation and structural strength, crucial elements for an aircraft operating at hypersonic speeds. This is not just innovation, it's evolution. The very process of how we build aircraft has changed. And in the case of the SR-72, this change not only accelerated development, it resurrected a program that was once considered too complex to exist. Additive manufacturing is not just a tool, it is a design and production philosophy that is redefining the limits of what is possible in aerospace engineering. The SR-72 is a testament to the power of advanced manufacturing, demonstrating how technology can transform ambitious concepts into operational reality, ensuring that America remains at the forefront of military innovation. No test flights publicly confirmed, no photos, no video leaks. But the signs are there, buried in press releases, obscure contracts, and casual comments from defense officials. The US isn't saying much, but they're saying enough. The absence of official information about the SR-72 is, in itself, a form of strategic communication, creating a veil of mystery that serves to disorient adversaries and maintain technological advantage. The strategy of keeping the project secret until the right moment for its revelation is a classic psychological warfare tactic, and the SR-72 seems to be the master of this art. In 2018, Lockheed Martin hinted that the SR-72 would make its first flight by 2025. Around the same time, unusual activity began at certain air bases. Black budget spending increased, and anonymous defense analysts began to whisper, "It's coming." These small clues, while not concrete proof, serve to fuel speculation and anxiety among rival powers, forcing them to invest in countermeasures and their own hypersonic programs, often without knowing exactly what they are facing. The combination of veiled statements and suspicious activities creates a scenario of uncertainty that benefits the nation holding the secret technology. If true, the Darkstar may already exist, and 2025 will not be its birth, but its debut. This is the genius of the American strategy. When the world sees it, it will already be too late to catch up. The revelation of the SR-72, when and if it happens, will not just be the announcement of a new aircraft, it will be a demonstration of power and a declaration that the US remains at the forefront of military innovation. The ability to develop and deploy such an advanced aircraft in secret and then reveal it at a strategic moment is a testament to America's ability to maintain its technological superiority and global leadership. The SR-72 is, therefore, a symbol of the US's determination to stay ahead in the technological arms race. The SR-72 is not just an aircraft, it's a paradigm shift, a machine that can gather intelligence, strike targets, and disappear, all at hypersonic speed. It's faster than any missile, stealthier than any drone, and more terrifying than any bomber. Its existence, even if veiled, redefines what is possible in aerial combat and sets a new standard for military superiority. The combination of speed, stealth, and strike capability in a single platform is what makes the SR-72 such a disruptive and transformative force on the global stage. Russia and China may be in the race, but they are chasing shadows. The United States, through silence and innovation, has positioned itself light years ahead. In this new era, war may not be declared. It may arrive, strike, and end, all before breakfast. The ability to operate with such speed and secrecy gives the US an asymmetric advantage that is difficult to overcome, allowing them to respond to threats and project power in ways that were unimaginable just a few years ago. The SR-72 is, therefore, a testament to America's ability to innovate and adapt to a constantly changing security environment. And if the SR-72 is just the beginning, what comes next may not just bend the laws of physics, it may redefine them, because speed doesn't just kill. In the 21st century, speed wins. The legacy of the SR-72 will be that of an aircraft that not only broke technological barriers, but also redefined the rules of military engagement, ushering in a new era of warfare where speed and agility are the most valuable attributes. The Darkstar is a symbol of the future, a harbinger of an era where air supremacy will be determined by the ability to operate beyond the limits of human perception and conventional technology. Did you like our content? Subscribe to the channel, leave your like, and share this video with your friends so more people can learn about the incredible story of the SR-72 Darkstar. Your support helps us bring more quality content to you.